Okay, a manufacturer wants to make trail mixes in protein bars, and these are the conditions. And if you change this into the linear optimization question, it's about maximizing this one under these conditions. And also X and Y are considered non-negative. I actually have a video explaining how to actually turn this word problem into this set of equations and inequalities, and that's in the first video of this series. So let's assume that we're given this problem. In this video, I want to explain how to solve this in Excel and also generate reports. Okay, so let me copy this over to the Excel sheet. Here's my Excel sheet. You don't have to have it in this format, but it's kind of helpful. So if you want to follow this video, you might just want to stop the video and make sure you format your spreadsheet. Just put all these things in there. I actually use the boldface here in order to make it this bold so you can easily read them. And I also use some regions and put some borders there using that, and you can do that. Okay, so let's assume that you have this, and I'll show you how to prepare this so that you can solve using the solver. Okay, so first what you do is, this is your objective function, and your objective function has the coefficient 40 and 65, so you put 40 and then 65 here. And then let's say this is the first constraint, which says 1 times x plus 4 times y has to be less or equal to 48. The second constraint says 3 times x plus 4 times y must be less or equal to 64. The third one says that 3 times x, no, actually the third one, this one, has 4 times x and 2 times y less or equal to 62. And you don't have a fourth constraint, so let's just leave it like that. Okay. Now, these will be your decision variables, and if you're trying to solve the linear optimization question using something called the simplex method, you have to populate this with some values. So we're going to put some zeros here. Optimal value will be computed using this times this and this times that. So here it should be something that's automatically calculated using those, and the way you do this is by putting an equal sign. So you click this optimate this point here, put equal sign. Oh, by the way, even the coloring right here, I used some, to make, even the coloring here, I used this thing here to make different colors. You can choose different colors using that, so you can easily see which one is which. You really don't have to have everything in this format. If you watch other YouTube videos, they will have their own format. I'm just trying something that would be easy to look at. Okay, so going back, you have this equal sign, and then I want 40 times the x value plus 65 times this value here. So that's what's computed here. Right now it's 0, but if you change the values here, let's say you put 3 here and then 5 there, you're going to see that this value changes according to the values here. And also, if you change the problem, of course, if you rewrite this as 50, that's also going to change. Let's put it back as 40. So you have this. Now, since this is a little confusing, a slightly better way to write this is to use the command sum product. Now, what the sum product does is, you first tell it what coefficients you use and what your xy should be. Then, doing this just computes the first item times the first item, and then plus the second item times second item. So it's a very handy function to use in order to populate these things. Okay. Now, the available for the constraints is same as this available, right? So we're just going to say that available for C1 is same as this thing. And then, actually, you don't have to say, the next thing would be to say that this is same as that one, but a quicker way to do this is just to drag it down here, and then these D4, then D5, the values after here automatically changes so that it correctly fetches these values. Okay, now the used is from these values, right? So you have 1 times 3 plus 4 times 5 would be the amount of ingredient used for C1. Remember, this was the box of trail mix bags, and this was the box of some protein bar packages. So for each of these you have certain quantities of ingredient C1 that you use. So you multiply this with this, this with this, and adding them up gives you the total amount of C1 ingredient C1 used. And again, the quickest way to do this would be to use the sum product. Sum product. And then you put C1's B3C3, comma, and then XY. Okay. So that's what you have. Now it's complaining here because I'm only using 1 and 4. I'm not making use of the 48. If that's done, somehow Excel gets suspicious. But it's okay. You just ignore the error and that's fine. Okay. Now the problem is if you do it this way, then you get some really weird numbers here because if you look at this, this is B3C3, B14C14. B14C14 are these two because it's at the 14th row and B and C column. Whereas this one is B3C3, so this is between B3C3 and B14C14. However, for the next one, you want 3 times this value and 4 times 5 value. So you really don't want the 14 to change, whereas you want to now have B4C4. If you look at the value here, it does have B4C4, but now you see that this is changed to B15C15. That's not good. So you really want this to stay, whereas this should change. The way you do it is, we go back to the formula, and if you put $signs for each one of them, then these will become fixed, even if you use this scrolling down, pulling down method. These will never change. So this is called the absolute indexing, and the first one is relative indexing. So once you have that, and then if you pull down, now you see that the correct values are computed. Okay, and with a lot of warning signs, let's just ignore them. Ignore. Okay. Alright, now because you want this to be less or equals to the available, your operator that you use will be less or equal to. Less or equal to. Less or equal to. Now, in some linear programming problems, you might have the inequality backwards. So it might be greater or equal to. So sometimes that could happen. In this problem, you only have this direction. Okay, good. So we have everything set up for the solver to run. Now, how do we use the solver? Well, if you go to add-ins, I just realized I didn't have the add-ins installed, but that's good because I can now show you how. So what I do is I go to this this search here and put add-ins, add-in, and look at add-in, then it gives you this box and it says here solver add-in. That's the one that you want to click and press OK. Then you go to data, and if you look at the if you look at this right side, you see the solver, right? So you click the solver, and you don't have that until you actually install the add-in. So this is the solver. This is the one that you want to use in order to solve by the solver. Let's see. Okay, so now how do you populate it? First, you have to set the objective. Which one are we trying to maximize or minimize? Is this one, right? So you click that, and that's good because, see, this is right here, this is B16, and I got 445, so that's good. And I'm trying to maximize. And then by changing variable cells, you know, change this variable cells, right? This is your X and Y. I populated 3 and 5. You can have anything there, but you have to populate it with something if you want to solve using the simplex method. So usually you put 0, 0, and that's fine. And then subject to constraints, and you start adding this here. So you want this 23. I have to click add. You want to add that this 23 here, this what is B19, has to be less or equals to 48. See, if you change the 3 and 5 to a higher value, then this will go up. But can you make it go up to infinity? No, you have to have it less or equals to 48. There's a limit to it, right? And that's the constraint that we're putting it right here. And depending on whether it's less or equal to or greater or equal to, you can choose which operator that you use. So right now, actually, this less than equal to is only as a reminder for yourself to do exactly what in the solver. So we're going to put this in the solver. Then you click OK. And then the solver appears again with that constraint. Okay. And then you have to do the next one and the next one. Well, the easiest way to do everything at once, assuming that the operator is always the same, in that case, instead of doing it this way one by one, you can just add, and instead of choosing just one cell, you can say that all these has to be less or equal to all these. And you add it, and then you press OK. Cancel. And then now you have that put in. And this actually single line is for all three constraints, so it's very convenient. And then you want to click this thing, make unconstrained variable non-negative. You click this, and that makes the condition that the X and Y cannot be negative. And then another important thing is, for the solving method, instead of GRG nonlinear, you want to choose a simple LP. The difference is they generate different reports, and this simple LP is the one that generates the correct report, which is used for sensitivity analysis. So you put this, and then solve, and then it gives you 8 and 10 as the correct solution, and the maximum value is 970, just like how we solved in the other videos. Now, you want to get some reports. If you want reports, you want to click all these three, and then click OK. Then suddenly, down here, you're going to see answer report, sensitivity report, and limits report. Now, to explain a little bit more about what these are, the first answer report is pretty straightforward. It just says that 8 and 10 is the 8 and 10 is the optimal value, and then slack values are 0. And you know, if the slack values are 0, then it's called a binding constraint. Whereas this slack value is 10, in that case, it's called a non-binding constraint. So this answer report can tell you which one is a binding constraint and which one is a non-binding constraint. Now the sensitivity report is about whether you can increase or decrease the coefficient of the objective coefficient to a certain value and still get the same optimal solution. So 8 and 10 wouldn't change even if you increased the 40 to 48.75, or even if you subtracted 23.75 to this 8 and 10 wouldn't change. This is actually pretty important because the markets always change, and sometimes you may have to change the prices that you get, the profit you get by selling those boxes, and you might be wondering, like, should I do the analysis again? What should I do if the price changes? And this tells you whether your previous linear optimization answer is still the same. Now, when you do this, it's important to know that allowable increase and decrease is assuming that this is fixed. So, assuming that the coefficient of y is 65 is fixed there, when your coefficient of x is between 48.75, less or equal to that one, 48.75, and what is 40 minus 23.75? That's 16.25. So if it's bigger or equal to 16.25 and less than or equal to 48.75, 40 plus 8.75 is that, then the solution 8 and 10 wouldn't change as long as 65 is fixed. Now, if both change, then we don't know whether the same solution would be used again. Okay. Now, what is the shadow price? The shadow price is about what happens if you try to increase this thing here. See, suppose you had some opportunity to buy more ingredient C1 at some higher cost. Now, should you buy it? How much should you be willing to pay for each additional of ingredient C1? Well, this tells you that if you want to go to 48 from 49, make sure that you aren't paying more than 4.375, because if you're paying more than 4.375, then that means you're actually losing money by increasing more ingredient C1. That's the concept of the shadow price.